Good evening. Please, am I audible? All right.
Loud and clear, loud and clear.
All right. My name is Bakel.
Yeah, good evening, sir. Yeah, your audio, sir.
Okay.
Yeah, you.
Thank you very much. All right. My name is Bakel Bakel. My first name is also my last name. Yeah, it was a network. Yeah. So I am a robotics engineer. I'm the founder and CTO of Aurora Robotics, and I'm also a naval architect too. But that's something I do on this. Um. Okay. All right. So today we'll be starting the first session of the series Why Robotics. And before we go on, I want to actually explain the reason why we decided to hold a series like this. And that's because we held our first workshop last year, that was in August. And during that workshop, people paid some money to register. But somewhere along the line, they found out that robotics was not for them, right? Because there is this picture that is being painted that robotics is like the next big thing, and it's easy to get along with or something like that. But when you actually start doing robotics along the line, you might find out that probably this wasn't meant for you. Or maybe along the line, you will find out that you actually was meant, like you were actually made for something like this. So this series is supposed to give you that clarity before you start spending money to learn robotics or to invest in components or different things. So we have a few guidelines for the class. I would appreciate if all mics are on mute, so with not background noise and every other thing. Now I am always looking at the chat box, so feel free to drop your questions there. And if you actually feel you need to speak, just politely raise your hands. It's going to send a notification and I'm going to see it and I'll get to you. I also recommend you take notes. Probably have a notes, or could be digital, could be physical, whatever. Because I tend to talk a bit too fast and drop random knowledge here and there. So that being said, let's go straight to why we're here. Today is the first day, and the first day is, I'm sure you must have seen the schedule for other days. Today is going to be focused on what robotics actually is, right? So it's more like an orientation class where we would explain thoroughly what robotics is. And to be frank with you, it's really difficult, right? That is one of those fields that you spend far more time trying to solve a problem than actually celebrating the problem. And it's more like, oh, we've solved this, so after solving this, there is always another issue to solve. Like it's pretty much that way. And even when you have a final product, you would always want to be upgrading this product, solving more issues with this product, and then we'll get to that, right? So I have this little meme. Every every field is complicated, right? It's not as if it's only robotics that is hard. Medicine is very difficult. So is naval architecture, civil engineering, whatever, right? And now we want to get clarity. The reason why we're getting clarity is because robotics is expensive to learn. That's one of the major complaints I got from people. Robotics is extremely expensive to learn. And I also understand that because I have gone really deep into robotics. So before you start, nobody wants to pay millions of naira and then find out that they don't like this thing, right? So that's what we are trying to correct. All right. So I don't know if anybody here is familiar with what we call a dot-com bubble. So a dot-com bubble is it was gotten from the rise of the internet then, when a new technology sort of comes up like everybody's talking about it, everybody's thinking about, okay, this is the next big thing, and then suddenly it goes away. We have like the metaverse, for those of us that knew how big that thing was in like 2001, the 2021 thereabouts. And then NFTs, they really rose real well, and then they dropped. We know of there are lots of examples we can come up with, right? So when you have all these nice trends and then everybody is running and rushing into it, there is always this speculation that this is probably just another bubble, right? It's another thing that people are just super hyped about, and it has nothing profitable at the end, right? So this is what we want to try and talk about today. If truly this is a dot-com bubble and why we feel it is not or it is. Now, the first thing we need to see is I've put together some reputable sources. This is the professor from UC Berkeley, and he is saying that he feels that robotics is advancing, but not as quick as people think it is advancing. So it's more like a hype, right? So people are projecting a reality that doesn't exist in a field that hasn't gotten that far. Now, whether he is correct or not is something we are going to find out at the end of this lesson. So just try and follow the whole train of thoughts. Now, before we start analyzing if robotics is or is not a dot-com bubble, let's first of all understand what robotics is. And this is going to take a good amount of time because you cannot judge you cannot really judge or say something about a particular field if you do not understand what that field is. Now, there are some bodies that govern robotics. When I mean govern, there are some bodies that, okay, these are like supreme bodies. You can reference them, you can talk about them. If they do say something, there's some form of authorities, both academic and industrial. One of those bodies is the IEEE, Robotics and Automation Society. So we all know IEEE it's the international body for electrical and electronics engineering, and robotics sort of falls under that. So that's why we have a society for robotics in IEEE. And they said robotics is the science and technology of design, manufacture, and applications of robots. That definition is very simple, but sort of vague if you ask me, because then it begs the question, what is a robot? Because it's just like saying cooking is the act of cooking, or is the act of being a cook or whatever. You still have a term that you have to define. Now, there's also an adapted definition of robotics, where it says it's an interdisciplinary branch, because it's a branch that combines mechanical, electrical, computer science, and a whole other branches. And we'll also look at that. At the end of the day, it's aimed for design, construction, operation, and use of robots. So again, we are falling back to the word robots. And still, ISO, which is the International Standard Organization for Standardization, they gave a definition of what a robot is. And what they are saying a robot is an actuated mechanism. Well, now, when they say something is actuated, it means it moves. And it can move in 2 or more axes. Now, this is a bit more technical, but understand it as, when you have a graph, XY axis, that is 2 dimension. Say, for example, your car can move front, it can move left, it can move right, but your car cannot move up, your car cannot fly. Your car can only move on 2 dimension and not into the 3rd dimension. Now, if you have a robot vehicle, like say you have a robot vehicle like this, something like this, it would be able to move on 2 dimension. So that qualifies the degree as a robot. Okay, yeah, it can move on 2 dimensions. So the things that can only move on 1 dimension is like a pump, or like when you have slider crank. Again, that's something some people might not be aware of. But again, a robot should be able to move. It's supposed to have some form of autonomy and be able to understand its environment. Okay, we haven't really gone to the time for questions yet, but you can drop a question in the chat box. Okay, So now let's kind of go away from technicalities and let's sort of relate it to real life, right? So if you are doing robotics, basically you are building a system that should be able to sense the world. It should be able to make a decision. It should be able to now act physically because of that decision and then work under uncertainty. I'll give you an example with autonomous vehicles like Tesla, Waymos. At least people know there are cars that drive themselves, self-driving cars. So let's say a self-driving car is moving on a road, and it has gotten to a point where it needs to take left or right. Right, the road it's a T junction. It terminates. There's left and there's right. And on the right, there's a barricade, so it cannot pass there. But the map, Google Map might not see that barricade, right? So it says there's a road there. Now, a robot is not just following an inbuilt map when it moves autonomously. It senses the world. So you, as a human being, you can see that barricade. The robot can also see it. The robot doesn't have eyes, but again, there are sensors that we use for that. I'm not going to go deep into that because that's another topic on its own. But on the surface, it can see that barricade. Now it can make decision. The decision is, I have to get off this road because it's left and right. Since right is blocked with a barricade, it only makes sense to go left. Now it has made that decision within itself. And now it has to act. The acting is to send probably like a command and say, okay, turn the tires left, and then we go left. Now it has acted. Now, working under uncertainty is the fact that when we're actually going, we did not know that we're going to have a barricade there. The road is not ours. Like suddenly we are there and there's a company constructing. It should be able to now adapt to all these kind of changes. So that's adapting to change, noise, failures. Adapting to noise is a very complicated thing to explain because sensors have noise and, let's just leave that. But at least understand the idea of a robot using an autonomous vehicle because that's the most popular form of robots. Now that's what a robot is. And robotics is the act of, building all of those things, bringing it all together and making it function as one. So it's a holistic field. So there is another video where I actually talked about what a robot is, what makes up a robot in great details. And the link, I'll also provide this slide so you can go through it. This was, okay. So I was talking about what makes up a robot. And I was saying there is a dedicated video, a dedicated class that we had especially for this particular topic. So we're just going to run over it because it's a really, really lengthy topic. So basically, a robot is made up of roughly 7 general parts, right? It's general because not all robots have these, but most of them, you can see the screen, right? But most of them have it.
Yes.
All right. So we talk of the structure, we talk of actuators, we talk of sensors, control systems, power source, end effectors, and communication. So the structure basically is the overall body of the robot. Just for illustration, I will also bring something like this. I mean, if you see something like this, like you can tell from the structure that, okay, this is like, it looks like a dog, basically. So you can tell from the structure that this should be something like a robot dog. And then in contrast to something like this, where you can easily tell that, okay, this is an autonomous vehicle or a robot car. So that's just the structure. It's the body. Now, actuators is the muscle. It's how they move. And they all have different ways of moving. For a car, you would be thinking of If it's an electric car, you've been thinking of motors, you'll be thinking of maybe mechanical, it's the engine. But if you are talking of, say, a quadruple, then it's those 4 legs. But those 4 legs are usually controlled by 12 motors, thereabouts. But at least you know what the actuators should be like. And then sensors. Remember when I said the autonomous vehicle can see the barricade in my earlier example? Yes, it can see the barricade using sensors. It doesn't have an eye, but then there are things like LiDAR, there are things like cameras, there are depth sensors. These are different ways it can sense the environment. Then control system is the brain. You know, when we said, okay, after sensing, it needs to make a decision. This is where it actually makes that decision in the brain. It could be a microcontroller, it could be a microprocessor. Those details are things that we can keep for now. Now, the power source, there are some robots that run directly on electricity. You just plug them in, and then some do have batteries. In any case, there must be something to power these components. That's why it's the power source. End effectors, on the other hand, is how it interacts with the environment. So some robot might not have any defectors. Say, for example, an autonomous vehicle might not have an end effector, but a robotic arm would have an end effector for grabbing, for welding, whatever. But that's how it interacts with the environment. And communication is how the robot communicates with either itself or with the control station. Now, in underwater robotics, we throw the robot inside the water, right? This robot is under the water doing inspection, doing welding, whatever. And then we're at the top. We're not with the robot under the water. The means of communication to get to that robot is Ethernet cable. So there's a very long Ethernet cable that we use for that. You might be thinking, oh, I mean, internet might actually be difficult. It has to be a wired connection because it's under the water. So that's communication and interface. We're going to look at the branches of robotics. Now, this can also be said as applications, but it's a very, very long list, and the list only keeps getting longer because people are finding new applications for robotics. We have industrial. Industrial is one of the earliest, and till now, it's one of the greatest applications for robotics, where we're talking about car assembly. You see all robots doing car assembly. You see robots doing general manufacturing jobs. You see service robotics. Service robotics, I don't know if you heard of Roomba, or all these vacuum that clean themselves in the house. You just turn it on and it cleans your whole house for you. Those are service robotics. There's medical logistics, space robotics. We talk of the Mars rover. Mars rover is one of the earliest space robots that is known to man. We have defense and security. Ukraine and Australian war, they use defense a lot, defense robotics.
Like I want now they force us to come start with this. But now once I do my best, I must say I do my best.
Ahmed, please can you mute your Ahmed, please can you mute your speaker? Your mic rather.
5:35.
Yeah, okay, I can do it myself actually. Okay. So I was talking of defense. Defense is one of the applications of robotics where you have autonomous UAVs, which is drones, defense drones, and all those kind of things. It's everywhere in the news. We have agricultural, marine and underwater. Oil sector use, all those oil rig, offshore rigs, they use these robots a lot. We have research and educational robots. There are some robots that are, will I say they are completely useless outside school, right? Like the Now robots. There's a robot called Now Robots. That robot finds no application elsewhere. It's just used to teach people how to start robotics, how to, just like Arduino is. It teaches you embedded system and how to just get started. And now we have, hold on. Okay, so while that is springing up, we're talking about research robotics, Now robots. We also talked about bio-inspired and legged robots. That's the one I showed you earlier on, the quadruple, the one that looks like a dog. Humanoid robots sort of falls here because it's bio-inspired and it's illegal robots. But then humanoid is in the category of social robots because of its application. We have autonomous vehicle, Tesla Waymos. We have the humanoid robots now. And then we have swarm and collective robotics. We'll look at this a bit more in detail. This is where you have so many robots at once and you want to, like, instead of controlling them individually, you want to control them as one. So that brings another section of robotics. And then we have construction. We have modular construction robotics is one of the fields that the UAE, Saudi Arabia, and then Kuwait, they are looking at it extensively because they have this project where they want to build some crazy infrastructures. Yeah, okay. We now have modular and reconfigurable robotics. This is the one that might interest some people because, you know, when you think of Transformers, Bumblebee and the rest of those guys, those Transformers cartoons or movies, they are actually robots like that in real life, and there are people that study it, right? Robots that will be able to change configuration from one form to another. And, you know, once you think about it as sci-fi, there's always a research team out there that will be willing to specialize in it. Okay, so these are the fields that make up robotics. Remember when we defined robotics, I said it's an interdisciplinary course, right? So one day you might be solving some complex form of mathematics. Another day you are doing control engineering for a PID. Another day you are thinking of integrating artificial intelligence, and somewhere, somehow, you're also working on the mechatronics part of robotics. So all these particular fields make up robotics. It's not as if you must know every one of them. We more like pick a thing or two from every single field, and then we just like squash it up together and then we make it robotics. So that's how it is. And there are some times where you might not even touch a field at all, depending on what branch of robotics you are working on. It's actually like that. Now we have fields that look like robotics. And that's one of the things I wanted to clarify far more than the branches of robotics or whatever. Fields that look like robotics: automation, embedded system, mechatronics, AI. It's a very, very strong confusion. And I want to actually clarify that with personal experiences too. The first one we'll look at is mechatronics. While there are some people that believe mechatronics is a part of robotics, it's actually the other way around. Okay, I'm talking about okay, so I should come again, you know, just fields that look like robotics. That's basically what I'm talking about. And then these are some fields that a lot of people confuse with robotics. And that's automation, embedded system, mechatronics. Yeah, mechatronics is the father, basically, right? So you don't put, there are people that say robotics is, look, when a field is being hyped, right? When a field is being hyped, a lot of uneducated people talk about it and it becomes irritating. It's just like the AI people, and we see a lot of people hyping AI, but only a very few people know what AI is, know what the capacity is, the capabilities. You don't put robotics, you don't put mechatronics inside robotics. Robotics is actually inside mechatronics, that kind of thing. So mechatronics is a broader field that combines mechanical, electronics, computer science, control to create intelligent systems. Yes. But now, what is the difference between mechatronics and robotics? In mechatronics, your systems must not actuate. It's not necessary for your systems to actuate. Now, for robotics, all robotic systems are mechatronic systems, but not all mechatronic systems are robotic systems. So there's a very, very clear distinction on that part. I took mechatronics courses, and in those mechatronics courses, some of them had nothing to do with robotics. Now that I work in the field and I say, okay, yeah, there is actually a clear distinction between these two things. Now we look at AI and then robotics. Now, first of all, it's obvious that majority of AI resides in software. What I mean by that is that, you see, AI per se, it's a computer science endeavor that is bent on learning data, recognizing the patterns, making decisions all within the software. None of this has to do with sensing the environment. None of this has to do with actuating, but it's basically the part that does the thinking if you look at it critically. So will I say robotics is inside AI or AI inside robotics? No, these are completely different sets of knowledge that simply intersect. So it's more like AI union robotics, something like that. Now, not all robotic systems must have AI in it, but robotic systems that do have AI in it make very smart decisions. And then it helps with perception, it helps with planning. I can go in and like more complicated things, but let's understand the basics, the idea. Now we look at automation. Automation is another thing that confuses people with robotics. Why? Because if you look at it from the outside, automation looks like robotics. Take for example, you have a factory line. You have a factory line of you have robots there, and what they are doing is they are assembling a car, for example. So let's create this little situation. The car door comes in, and the car door, the height of the door, say it's 3 meters. That's 3 meters. And then there is a weld that should be at the top at 3 meters. One machine welds at 3 meters, it moves to the next one. And then let's use that example. In automation, they've defined these rules for them. Once the car door comes, go straight up to 3 meters and weld. What happens if you bring a car door of 1 meter? It's still going to go up to 3 meters where there is no car door and attempt to weld the air. Now, the problem with that is it's not sensing its environment, but it's extremely precise with the instructions they gave it. So it looks as if it's a robot. All this is just automation. The environment that they put the automated bodies in are so controlled that they have to perform properly. Now, a robot, on the other hand, if you bring a car door at 1 meter, it will go down to 1 meter and weld. The robot should be able to adapt to those changes. And how will it know? The automation does not have sensors. I mean, some do, but in this example, it does not have like a camera sensor to tell the weld is up there or the weld is where. Hold on, let me join the second meeting. That's loading. So in short, automation will always follow logic. There's a predefined rules and all of that. Whereas robotics actually require awareness and ability to adapt. So automation is more like instrumentation and control. I can say they apply that, right? I cannot impose or superpose one field on another, but I can see they do apply that. Yes, the slides will be shared in the class. I can actually do it now, but it's going to divert. All right, the next thing is embedded system. And and for embedded systems, robotics will not exist without embedded systems. That's one. And I'm going to share a very funny, yeah, the class is recorded. I'm going to share a very funny story. Now, I was in Netherlands, right? I traveled to Netherlands. I went for this professional training, and okay, so I was narrating my embedded system story. So prior to that program, prior to that certificate, prior to that training, on my CV, I had a place robotics engineer, and then I have another place I like embedded. So like I've always thought that okay, yeah, I'm robotics and I'm embedded. Why? Because I know how to use microcontrollers, I know how to use microprocessors, I know how to use a lot of tools. So somewhere in my head, I'm thinking, okay, yeah, that's enough to be an embedded system engineer. So I have robotics and I have embedded system engineer on my CV. So I actually go to this place, these competition events in Netherlands. There were guys that were doing robotics and there were guys that were doing embedded systems. And I went to the embedded system guys and we started talking. And when we started talking, I started hearing things I've never heard before in my life. And these guys were telling me things like RTOS. Okay. I'm like, okay. And then we're talking and talking, and then someone is telling me about memory architecture. I'm like, all right. And then people, okay, we start talking. I mean, but these are things that, okay, RTOS, real-time operating system, I can infer the meaning, right? Because I do robotics, I can infer the meaning. Memory architecture, okay, at least I know what memory architecture is. Okay, so we're talking. And then they start telling me something about FPGA. And at this point, it was clear I didn't know embedded systems. Because I had to like Google FPGA, okay, field programmable gate array. I don't know what it means. Everywhere blur, I kid you not. So what broke the camel's back was when they were talking and they were like, oh, so like von Neumann, and then we're talking about memory philosophy. Oh, memory philosophy. And at that point, I got back to my hotel that day and I removed the embedded system from my CV because the worst thing that can happen to somebody is to claim what you are not, right? So I removed the embedded system from my CV that day. But then I ended up understanding something. Because you use something doesn't make you the person that understands something, right? If not, everybody that lives in a house would be an architect because they actually use the house. They know where the kitchen is, they know where the door is, they know where they, I mean, if you tell somebody two-story building, everybody knows the two-story building is, but that's not enough to actually make you an architect, right? So the fact that I can, I mean, if I'm trying to build a robot and if I'm trying to build a robot and I find out that on my microprocessor, I have only 4 USB ports, like a Raspberry Pi, but I want to connect sensors that need 6 USB ports. Because I'm a robotics engineer, I know that I need to buy a USB expansion circuit or a USB expansion PCB. So I will just source for it quickly, I would get it, and then I'll expand, and then I know how to use it. That process of me knowing what to use is not the skill sets of an embedded engineer. That is what you are supposed to know as a robotics engineer, right? You are just simply going out a bit to borrow from another field. Because if they sit you down and tell you that USB expansion board, design it from scratch, then you actually realize that, okay, yeah, I probably should not be saying I'm an embedded engineer. Right? What am I saying? Respect your field. Try and define your field. I'm sure there is somebody somewhere that can do robotics and embedded and do all together. Splendid. But at least respect, know what you are doing when you are doing something. So yeah, that was the inspiration when I was creating this meme, right? Because I was literally the train trying to cross that track until I saw embedded engineers. All right. So that was basically how it worked for me in Netherlands. And then I had to learn that too. All right. So somewhere along the line, we have this giveaway tax, right? So in March and April, we are going to have our workshop because the workshop is every year. We have like 2 every year. The last one was in August. But if there's something about Aurora and the way we think, we try to set tax at events to help people actually grow or like to point them in actual direction. And then we have some few incentives. So basically, each task you complete is just to help you be consistent every day, right? To show up every day because you know, okay, there are some things you would actually earn. Now, basically, each have points, and each point actually turn into the percentage discounts that you get on the next training. So there's going to be a tax at the end of this class too. So let's also try and follow up. All right. So what have we talked about? We've talked about the theory of robotics, like an overview, the branches in robotics, the fields in robotics, and other things in robotics. Remember, we haven't solved the problem of whether or not robotics is a .com bubble. We are going to go back there. But for you to still understand it, you need to understand what robotics is. Now, let's look at robotics from my point of view. And when I mean my point of view, I want to look at, I want to make it a bit personal. So, my journey in robotics is, it's a bit strange. Some people think it's impossible, but then again, I mean, I share it, and it's on my LinkedIn. If you followed me for a very long time now. Now, I started as a naval architect, and that's where my, oh, you're just joining. Okay, congrats. I started as a naval architect, and that's where my major training and my experience is, right? So, my undergraduate was naval architect, was at naval architecture. My 2 masters, naval architecture. So basically, that's what I have been doing. But then I switched to robotics in November 2024. And the way that happened was a bit funny because I've always known about robotics, but I have never really done anything about it. But then there was an elective course we had in my master's, that's my second master's in naval architecture, where robotics was an option. So I was like, okay, let me just try it. And I ended up turning that elective course to a career because I started, it was not enough to make a career though, but I mean, you research and you add other things to it. So on the right is this nice code, C++. It basically says the same thing. If you already write C++, congratulations, you probably will understand this. If you do not write C++ and you love to learn, then stick around. Now, I started with mobile robots, which is usually the place everyone starts. Mobile robots are robots that move on the ground. It could be fully autonomous, they could be semi-autonomous, but at least we know what mobile robots are. And I got accepted into Prisma Lab. There's a whole story behind it because that elective course, we don't have exams for that elective course because nobody takes it. Marine engineers and naval architects don't really like robotics. So what we're supposed to do was to submit a 15 pages report, right? But I sort of started liking robotics, and then I started teaching my classmates, which were also naval architects. I started teaching them robotics, and I made it look really interesting. So it was fun to me. But then I wanted to be accepted into the robotics lab, right? The robotics lab in question is Prisma's lab, and Prisma Lab is the 21st best lab in Europe and the best lab in Italy for robotics, because the school was not, well, the school was not a small school either ways. So I really, really wanted to be in that lab, but you can't just get into the lab because you're even from naval architects and you're not even in robotics, something like that. So what happened was I wrote this 15 pages report that were to submit. I actually wrote 60 something pages because we're doing kinematics and inverse kinematics. These are things you also know of if you attend the workshop, or maybe you read about it. I went deeper into it. I explored things like Jacobians. I literally turned the elective course to my main course. And it was really impressive to the professor. It was impressive to the people who took the elective course. And somehow, they accepted me into the lab from that. And that's where it all started. So, really engrossed with robotics. And I spend a lot of time with it every single day. Again, let's follow the story. Now, I started doing underwater robotics. What happened was in Italy, I worked there for like 3 months, and then I moved to Spain. And while I was in Spain, anywhere I get to, I look for the closest robotics association or the closest robotic gathering. And the one in Spain was underwater robotics. It wasn't mobile robotics like I knew in Italy. So again, I had to start learning things again. And I was like, it's robotics. Robotics is robotics. So anything robotics. That basically I came up with that. And then I played around with underwater robotics for 5 months. And then at this time in Spain, I was still doing my master's in naval architecture. But the professors in Spain, they were like, okay, I mean, this kid is actually good. So they started inviting me to come and lecture other master students in robotics. And then people mistook me for a postdoc in robotics because I was always in the robotics lab and I was always working. But then I was just there for fun. So this is me. At this point, they were inviting me for trainings and I started training a lot of people, and I wasn't being paid for it actually because I'm just doing it for fun. So that's how it all started. And then I got some PhD offers, and when you're putting yourself out there and just exposing yourself. So I started doing competitive robotics. But tomorrow we are going to talk more about competitive robotics because we have a guest speaker, Saka, which actually does competitive robotics a lot. But from my own end, I went for this European Institutes of Technology competition where my team actually won. And it was actually one of the biggest points in my career where, I mean, it was a flex because we got teams from the US and everything. Right? So it was a big flex. But it was a funny situation because immediately after this competition, I went for another competition where I couldn't even finish the task. So it was a very funny week for me. It was just one moment you're high and then another moment you're being reminded that you should be humble. Okay, so I actually enjoyed. I enjoyed the game. I represented pretty well, and it was a nice experience for me overall. Um, okay, I can see the other people are also saying. Okay, now Area Robotics. Most of my experience from Area Robotics is from Prague, which is Czech Republic. I'm someone that travel a lot. I enjoy traveling, so I'm going to be calling different countries. And I travel most times. When I travel again, I look for the closest robotics association. And for me, I just walk straight in. I'm like, okay, I want to do robotics. So I worked on Area Robotics. I saw really big drones, right? So most times we deal with drones that are like palm size, but like I saw really, really big drones because we have big drones that had lidar, that had a lot of things. So they were investing millions of euros in this particular field. Then bio-inspired robotics. For those of us that have probably heard of the unit tree, those walking dog. Yeah, I had a smaller version because I mean, why not? But these like the big ones, right? The big ones are like really, really expensive. So this was in Greece. I went for this particular program. We did this training. It was nice. I played with different classes of robots, right? Now there's this clever thing that some people are doing. When you have a dog, what they're very, very good at doing is smelling or sniffing things. So they are trying to like use these dogs to create an artificial nose called an e-nose. And then it just kinds of like sniff things around. It's complicated, but it's ambition. Now, industrial or field robotics. So I started my whole professional robotics not so long ago, and I've had the opportunity to work on a lot of projects, including energy plant inspections, robotics for constructions, a lot of things, right? So that's not the main focus, but what I can say is companies spend millions of dollars just for robotics. So that's something that I read on the news. It's something I see. It's something that like in a week I can get like 2 to 3 offers like, hey, when come and join our team, things like that. And there was a time, even Chevron and Shell, there was a time invested quite a lot of money. This was late last year to acquire a lot of robots and to acquire people that will create and program these robots. So it's actually a big thing for us in the field. Multi-robot systems. I told you these are systems where you have so many robots, but you are not controlling each of these robots, right? You control all of them as though you control one. I'm sure you people must have seen, those Happy New Year things, those drone shows where you have so many drones, right? But the problem with that is those drones are centralized, right? There's a common control station where they just control all of them, right? It's a nice show, but if you change the terrain to what they do, then it becomes a different story entirely, right? So what we try to do is you see the way birds fly in flocks and they adapt to the environment, they move around, nobody controls everything, but one robot or one bird knows the location of the next one and they just move together. That's what we try to replicate. So I actually worked on this as a robotics control and planning engineer. Again, remember we said robotics has control systems in it. So control system, that's what I focused on something like this. Manipulation robotics. This is one of the popular ones. You have robotic arms. And this is what we focused on our last workshop. So here if you check on the bottom, there's a link, and that link actually sends you to a repository that contains a lot of these robotic arms and the industrial applications, right? Because whenever we do these workshops, we don't focus on theories. We actually look at how they are being applied in industries and jobs that we've actually worked on. Now, embedded robotic systems. You remember when I said embedded is different from robotics, right? There's a field where you run all the robotic systems solely on an embedded system. Like you don't actuate, it is a very new field. So new that most big companies started doing it last month, right? That's how new it is. So it's not something we'll probably go into that much, but basically you can see there is a robot on the right, there's a robot on the left, and then there's this tiny board. This board is an NVIDIA Jetson Orion, and this is the board that runs the embedded robotics. Probably some other time we can go into more details. And then defense robotics. As the slide implies, I can't say much about it, but yes, I love to. But I've been here. I've been here a couple of times. So thank you very much, as you understand with me. Now we have the .com bubble. Now let's go back to the .com bubble. Do we have a .com bubble? Now the first thing is, let's look at the metrics. At the bottom, you can see I have links that does what? That sends you to where all these informations are from. Why? I am a hater of AI. I know it's ironic, but yeah. So I prefer when there's like you actually read these things, you see the links, you see the actual values rather than just getting information elsewhere. So we can see that there's actually growth in industrial robotics. And that growth is inevitable. I kid you, that growth is inevitable because in industrial robotics, the more industries that open up, or the newer industries, like the newer fields, like agriculture now is opening up a bit more, you tend to see robots in that field. Anything that, like, once an industry opens, there's going to be robots. Because people would always look for easier ways or look for machines that will do things for them, right? Now, the report is the amount of robots installed alone. Like, we're not talking about the cost of maintaining them. We're not talking about just the value of the robots installed is about $16 billion. And that's an extreme number. And that's a very, very large number. Now, some people are projecting that the growth of robotics would be at 60 billion by 2030. 2030 is just 4 years from now, and for us to get that growth, there's a lot of work that is going to be done. Now, there are some tasks that will always deploy robots for. Welding, assembly, pick and place. Pick and place has one of the most popular things in robotics. Once you get a robotic arm, the first thing you do is pick and place. So we have companies like Shell, Chevron, and Ardentia. And these are companies that I have interfaced with. And I actually know that, okay, yeah, these guys are actually very serious about this thing, right? And we also have at Aurora, we also have our own projects, our own industrial projects that we're working on, but it's not yet out though. But and then we have service and logistics. These are consumer robotics. There's deliveries. We see Amazon, they also deliver with robots in some areas of the US. If that kind of thing gets approved worldwide, and maybe like think of how many units. Now in 2024, there was increase in 200,000 units of cleaning robots and delivery robots that was bought. So people actually took out $10,000 greater, like $10,000 above, and bought some of these things. And where I work, I see I'm the one that actually approved purchase of robots. And at times I step back and I stand outside the company and I look at everything that's going on. And I said, people are actually willing to spend this amount of money to actually invest in robotics. And I'm like, okay, yeah, there's actually it just can't be a dot-com bubble at this point. But we're not making that conclusion yet. We are still going on to see some other things. Humanoid robots. With all the chess that I have, this is one of the controversial areas of robotics. Because why? Humanoid robotics is that part of robotics where you design a robot to look like a human being. And my major problem with it is that human beings are inefficient. That is why we are creating robots. So in what world does creating a robot to look like a human being solves the efficiency problem? Now, I'm not bashing humanoid robots. Why? Because I also worked there. I've also worked there, and I'm still going to work there if the offer comes and the offer is good. So I can't bash humanoid robots. But going back to the truth, right? Humanoid robots, it's a long way from where we are going to, or where we think it is, because now we are teaching robots how to fold clothes. And if you watch those videos, it's a bit sloppy, but it's trying to get the job done. We are training robots how to fight. It's not the most ethical thing to do, because if a robot that is made out of aluminum knows how to fight, it's a lot of problem. But we're doing these things, right? And when Leonardo da Vinci was doing a lot of innovation, then people saw him like a madman. And then Vincent van Gogh himself, his paintings, people looked at him and they're like, he's a madman. But later on, it all started to make sense, right? So probably humanoid robotics now doesn't really make much sense, but the prospects in it would actually make sense, right? So particularly in this job, I was to train the humanoid robots to there's a video of this on LinkedIn. I was to train the humanoid robots to communicate. You know, remember we put humanoid robots and social robots together, humanoid and social robots. And the idea was, since there's humanoid robots, let's make these humanoid robots to be able to talk to kids that have autism, to like interact with them and all of that. So that was the idea here, and I got that done. So you can see it's sort of like a brain, and let's not go too technical, but yeah. So humanoid robots is one of the reasons why people feel there is going to be a burst, because if you check, most of the companies that go bankrupt are humanoid robots. And then somebody actually forecasted that only 20 robots, only 20 companies will end up comfortably producing humanoid robots by 2028. In the US alone, there are far more than 20. In China, there are so much in China that the Chinese government had to actually regulate how many can be again. Like, you can't just open a humanoid robotics company in China. That's how much they are. So, another question that we encounter, is it taking more jobs or is it creating more jobs? In my opinion, it creates more jobs. But it also takes a lot of jobs, right? Let's assume we are now, a very good application is I think that was 2023, where Amazon laid off how many thousands of staffs and replaced them with robots. Now, the amount of staff that has been laid off and the amount of robotics engineers that have been brought to replace them is, you can't compare it. Right? There are fewer robotics engineers, but then I'm a fan of, I'm not a fan of evolution, but like, it's more like, yeah, it's sort of evolution. Darwin, right? The strongest should survive, right? People that are able to notice change and react to it are the only people that deserve to survive. I'm a fan of that. So probably if you were someone that sells horse or that was selling horse, and then the car comes up, you would get so pissed because now people will start driving cars and nobody will buy your horse. But then the world does not owe you anything for you to be stagnant. So what you do is, you're probably going to start looking for a way to sell a car to and change. And so that's how I look at it. So yeah, it creates more jobs. So it's just for you to switch into whatever new trend that you deem fit. So now, what's our conclusion, or what's the conclusion from everything? Humanoid robotics are going to like slow down because it's not as practical as possible. Things that thrive are things that have business associated with it, that are making money, and robotics is actually making money. Because look at Waymo. Waymo is making money from just autonomous vehicles. Nobody is driving them. So things like that will continue to thrive. So that's how you find out things that are not just dot-com bubbles. Because when a government sees that people are making money from this thing, they would always support it to like thrive. Everybody wants the GDP to grow politically, whatever. So it's not a dot-com bubble. You can also review the materials that I sent and I attached. They are all things that you can go through and make that inference by yourself too. Now, now that we know that it's not a dot-com bubble, we have a rough idea of what robotics is. We have looked at different branches and everything. I want to now talk a bit more about the company that is bringing this training. Okay, because we want to know more. So basically, we are a Nigerian company, obviously, and we are built by a team of highly skilled and talented robotists. First of all, it surprises people when I say we are over 30 over 30 staff and interns, because most people see it as my company, or I'm the face of the company, clearly, but there's a lot more collaboration that goes behind the scenes than we can actually even think. So I actually give credit to all those people that have been around for a very long time now. Now we are into education, which is the first point of contact. This is the first thing you notice. We're into education, we're into software development, and then we are going into hardware designs, plus or minus. But then we're heavy on competitive robotics too, because that's a field that we're even going to talk about it tomorrow. So let's leave that till then. Now we also have what is called interstellar, right? If there is one thing about our philosophy here at Aurora, is we believe in community growth, right? As we say, nobody is self-made. I don't think anybody is self-made. There are people who claim that they are self-made, but look at it critically. Are you self-made? Even I am not self-made. Along the line, somebody must have helped you somewhere. think of it clearly. You are probably not self-made. So we have this network that, okay, yeah, you can share information, you can get together, and basically it's something in progress. I'll still give more information on how we can be part of this network in the coming slides. So basically, why are we doing this? On this call alone, you have seen me bridge the gap between the fields that look like robotics and practically why they do not look like robotics or why they are not robotics. So you can easily tell that, okay, these people are not here to just do what universities generally do, which is to teach you. It's a more practical stuff, right? Sharing experiences, sharing ideas, being hands-on with things is one of the core responsibilities that we decided to carry on our shoulder. And I want to build a community of indigenous talents. A friend once told me, it seems you have somebody for everything. If you are looking for a cinematographer, if you are looking for animator, if you are looking for someone who does web dev, almost every tech skill, somehow we know somebody that does something like that. So that's that kind of thing. You see, Nigerians are extremely talented. Like, you have no idea how talented Nigerians are, because I'll give you a little explanation. You are in Nigeria now, network is against you, NEPA is against you. I mean, you don't even have consistent light. The education system is bad. You just come to class, your lecturer dumps the handouts for you, and then. But regardless of all these things, you still somehow thrive. You push through, and you come outside. You become international, right? And then the first thing I noticed when I first came to Europe is, look at how easy life is. I mean, if you could thrive in, say, for example, now you have a gas, you compressed gas, and then you've gone through that stage, and then suddenly you come to an environment where they take away all that pressure from you. What happens is the gas in you actually just explodes, and you sort of just bloom into the best you can actually be. So how do I put it? It might be a gift, it might be a curse, but in any case, we Nigerians hold a lot of potentials. And I actually like seeing people maximize that potential. And I say, okay, yeah, this guy actually did it to the best that he could actually do it. Another thing is, want to prepare young engineers for masters, PhD, and career opportunities. So, say for example, you win an internship with the company. We have a research track where, okay, all we are doing is we are focusing on writing papers, contributing to research, validating on real robots, and all of that. These are things that would actually push you in a way that, okay, yeah, you have your masters, or you are going for your masters, just shows you. And now, okay, we also want to showcase that Nigerians can lead in robotic innovations and things like that. And then to inspire consistency and passion. Look, you can be passionate about something and you can make money off that passion, right? So we're also going to inspire things like that. So basically, I want to give a little overview about the team and how the structure is, right? So you have an understanding. So we're basically a product of community efforts. It's not one man, it's not one person. We have 3 branches. We have associates, we have the core, and we have directors. We have about over 20 something associates. We have 32 in the core, and then we have the directors, roughly 5, 6. Now, the associates is that arm of Aurora that actually gives us traction, right? So you probably must have seen your friend about us. You probably must have seen somebody who moves as though he works with us. Yes, he is. He is a representative. or she is a representative. So the way it works is we prefer having this networked system where we are sort of far apart but together, and we know what brings us together is this innovation and things like that. So we have the head of associates. A few of us must have actually come in contact with her, Ogenekewe Vikosin, and this is just giving credits to her for organizing things so far, right? So she's the person who organizes the structure for the associates and reaches out to everybody. She's just the one that checks up on associates and things like that. Now, we have associates for communities, we have universities. Anyway, remember what I said. Once I get to a place, I check for robotic associations or communities in the place, because that's what makes me feel alive, right? Doing these things, it's just contributing, makes me feel alive, and I become part of it. Now, if you're in a space like that, you're in a tech space like that, you can also be a voice, right? You can also talk on behalf of Aurora. You can also say, okay, yeah, this is also what we do and things like that. Then we also have that on the university level. At this point, we have a few universities that work with us. Bells, credits to Mainsword David, Covenant University, credits to Alini and some others. We do have Abward, maximum respect to Princess, and then a lot of other universities, right, that I cannot mention. We have Samuel Obialo from IMU. Yeah, we also have AKSU. Yeah. So basically, it's community effort, man. I mean, you don't become great on. I think there's a saying: if you want to move fast, you move alone. If you want to move well, you probably move with a lot of people. So maximum regards to everybody. And yes, this is Princess. So Princess is the strongest associates of Aurora. If you just search for Princess on LinkedIn, I'm pretty sure you are going to come across her. Search for her on Twitter, you are definitely going to come across her. When they say somebody is an embodiment of passion, it's definitely going to be Princess. I remember the first training we had, which was last year in November. She was the person that introduced us to Abuad, and a lot of credibility that she has. She actually put it up for Aurora when we had no form of credibility, right? So we have Divine. Divine will be speaking on Wednesday. She is a first class graduate of History and International Studies. Now, you can see how we are in robotics, but somehow we have somebody in History and International Studies. At the end of the day, it's not really about what you study, right? Because I myself, I'm a naval architect, but look at me being all good in robotics, right? So basically, she is that person she's that motivator, right? We've heard of motivational speakers, and there's this around motivational speakers that we need to catch one motivational speaker one day and beat them. But this is quite the opposite. She's one of those motivational speakers that would, you just need to hear her speak on Wednesday. Just don't miss it. That's all I can say. Now, those are a few associates that we do have, and then these are the benefits that associates get, right? It ranges from 100% free access to all our trainings, full access to our resources, and in some cases, revenue share. I know there's some people that are very, very business minded, and business is fine enough. Person don't say sharp, just now. All right, now we have the core. The core of Aurora is the people that are, for example, this meeting kind of went sideways. For some reasons, we cannot take more than 100 people. And now there are people working at the background to get things up and running. Now we have another meeting too. I think people are also joining that one, right? So these are people that we give credits to. I'm up here talking, and people are trying to fix things at the background. They are both the staff, the interns. These are engineers, developers, leads. These are people that directly contribute to the GitHub repository of Aurora Robotics. And We do have some of them that we have picked out for the week. Margaret Obasuyi, so he is actually the staff of the week. He's one of the earliest people that I worked with Aurora. He prefers underwater robotics, just like he met me when I was doing underwater robotics. So he actually loved underwater robotics pretty well. Right now he's in the UK and he's working on his studies on marine engineering technology, which definitely involves underwater robotics too. So he has been very helpful. And then we have the intern of the week, which is Great Osanya Day, who is one of the brightest persons I've actually come across. Brightest and ambitious, very ambitious. Remember we said we have research tracks here at the company, and he's working on neural robotics and learning-based quadruple system. So this is a project that he's working on together with Sahid, notable mention too. And what he's doing is he's basically taking this robot or something like this robot. It could also be unitary, and we are saying let's control it as though it has a brain, right? Some form of cognitive robotics. And I'm the one also supervising because I am also getting my PhD in cognitive robotics. So we're basically building things up, and it's fun to learn the whole process and make some money off it too. Now we have the directors. The director of the week is Saka, and he's going to be speaking tomorrow. Now, you see a portfolio like this, and he's going to be speaking on competitive robotics. I have won a competition in Europe, right? I mentioned it, but this is someone that has won first gold, first top, first runner. It's someone that has won. Yeah, Astro. I think Louted boys are also here. They've seen the Alga. So Astro works with us, or Saka, he works with us for competitive robotics. Now now there's a competition where there is a lot of money at stake. It's by Intrinsic AI, NVIDIA, for all those of us that know NVIDIA. And what we do at the company is we do have a team that shoots for these competitions, right? Are we going to fail? No, we don't think we're going to fail. Well, yeah, there are levels to this thing. So basically, we are going to hear from him and his journey in competitive robotics tomorrow. Now, about me. So I realized all I said was I'm Bakel and I'm the founder and CTO of Aurora Robotics, but there might be a need to fully explain myself. We actually get to know ourselves better. So first of all, a friend of mine called me and said Google search actually brings up something for my name. Fair enough. So I tried it. And according to Google, they said it refers to a specific person, a Nigerian robotic expert, an Erasmus Mundus scholar in Italy, passionate about marine robotics, AI, IoT. Okay, yeah, that's what Google has to say about it. Google equally brings up a LinkedIn page, which is my LinkedIn page, aside some other things. So my background, according to them, allegedly, I study in Italy, and I'm an Erasmus Mundus scholar. Specialized in robotics, marine engineering, autonomous navigation, industrial Internet of Things, and artificial robotics. I worked on DTT. So DTT is the nuclear project of Italy. I also run the Aurora Robotics training. I said my focus area is path planning. If you remember some slides ago, I showed a project for the multi-robot where we worked on robotics and planning. So I think that's where that is gotten from. Localization, motion control, perception system. ROS2 is one of my biggest strengths. Why? Because ROS2 is extremely confusing, and it's something I like because of its complexity. And then industrial automation. Of course, it's Google, so it brings up other things like skincare, ingredients, and some other things, but that's basically not me. And then somebody said, apparently, it was my brother who said this, that he tried searching for me on ChatGPT. Somehow, I showed up. So for it to be fair, I know if I actually search for it on my own account, it's going to show up because I use my account clearly. So we actually have an account where I wasn't logged in, and then we tried searching for it, and it's pulled up some things. Okay. And apparently, I'm a person with social presence on LinkedIn who appears to share insights on robotics, technology, and learning experience, which is true. I do make daily posts on LinkedIn. I used to be a bit more consistent, and everything still circles around robotics. Yeah, for people that have actually come across my Upwork page, I'm a top-rated robotics engineer. So usually top-rated robotics engineers are people that are within the top 10% of global engineers. So if you're on Upwork, it has the way it just ranks. And then there are people in the top 3%. Those are top-rated plus, right? So I'm not top 3%. So like I'm a bit below that type, but yeah. And it has a summary on some jobs that I've done in. It's the internet actually. Now, what do I have to say about myself? Well, I'm a lot of things as you've seen, but for this week, I'm going to be a host for Why Robotics seminar, and we're going to be going through the rough terrains of robotics, right? We're almost at the end of the program of for today, right? Because it's supposed to end at 8:30. So robotics is something I can keep on talking about for hours, and provided there's someone willing to listen, I'm always willing to talk. Now, what are the expectations? What do I expect from you? I expect consistency, right? Right now, we have over 100 and something people on the call. By tomorrow, we're going to fix the whole issue, so we're going to have a lot more. But if you are here today, be here tomorrow. And if you're here tomorrow, be here next tomorrow, and keep on going. Reason, consistency is very difficult to build. But yeah, that's why we came up with those incentives, right? The tax every day for you to keep you up. Yeah. Now, curiosity. There is actually an award for curiosity in our workshops for people that are very curious, that ask what if and why, right? So reflection is one of the things I expect, because not everybody on this call is going to proceed into robotics, which is the idea. The idea is for you to know if you want to proceed or not. So don't just come here to hear about robotics and find it interesting. Actually sit down and reflect. Okay, this thing that this guy is saying, will I really want to do it? Because I kid you not, between like sleepless nights is a lot of things you think of when you're coming to a field this competitive. The internship is it on the site? No, we'll talk about that very soon. Collaboration and then respect. I'm someone that respects, like that I respect, right? So respect time. Some people were on this call very, very early. I maximum regards to you guys. Some people came on time. I respect space and respect each other. What are the assignments given? Don't worry, it hasn't been given, and I would also recap on the group chat because it's our fault that so many people were not here. So don't worry, we have that factored in. Expect from me, you should expect pure facts, and one of the pure facts that I've actually put up here is there is this constant debate of hardware versus software, right? And I am a software person, right? I'm a software person from day one till today, and I despise hardware. But if you are very, very conversant with computer, you will know that the first piece of software was actually hardware. And that's how it has been. So hardware supremacy is actually right. But hardware cannot do without software. I agree. I actually do agree, right? How can you be in the group? Um the group link on the chat. Someone would send the group link on the chat. in your lab or someone if you're on this call. Princess, please. Yes, before there was software, there was hardware. Yes. So hardware wins. But no, hardware wins. There's no but. All right. What's the mindset? Curiosity over perfection, right? There is nobody that is perfect, right? Consistency beats intensity, right? You cannot wake up one morning and give 1000%, the next day you give 0%, the next day you give 10%, and then you just fluctuate like that. No, it doesn't work that way. It's not the best practice, right? So you try and be consistent, right? Now, collaboration over competition. Yes, I said we are into competitive robotics, but we're not competing against ourselves, right? We are not competing against ourselves. We are competing against other people, and we're trying to show that, oh yeah, we're actually best. But within ourselves, it's a lot. That's the idea. Someone brings this, another person brings that, and then we'll bring it all together. Now all of us gather there. So this is actually the link, but I can see that somebody has already put it on the chat. So that's great. Now this is the tax. I would still provide us with this slide. I understand that from this call, there are people that would not want to go into robotics, and there are people that will go into robotics. But there might be people that would want to go into embedded systems, because embedded system is one of the most accessible things aside robotics. I mean, AI is also accessible too. Like I'm speaking from the demographic that we have in Nigeria. Now, your favorite engineer is the close partners for embedded systems with Aurora. Remember, I said robotics only uses embedded system. We do not create embedded system, basically. We just make use of it. So there are people that actually specialize in that aspect. And the task for the day, which is what I will still put on the group, is you probably should also learn about it. Even though you do not want it, or you feel it's not meant for you, look at it first. The same way you are looking at robotics to check if it's meant for you, because all these are in-demand fields. So there's a link. You go to that link, and then it gives you a very short form. It won't take 5 minutes. But then there's a question that asks for your status. So if you are a student, you say you are a student. If you are working, you say you are working. But besides your answer, fill in Aurora. That's the example here, AURORA. And that's the keyword I would use to actually award the points to people that fill. Of course, your email address is there, so we know how to keep track of all of that. So that is the task for the day. So at this point, Q&A and story time. But before I take Q&A, I'm going to run through the chats. I'm going to run through the chat because I saw questions on the chat. The first question I can see is if there will be Q&A. Yes, there will be Q&A. Mechatronics is the father. Yeah, Mechatronics is the father of things. The slides will be shared after the class. Yes, the slide will be shared after the class. Someone likes aerial robotics. Yeah, I also do like aerial robotics. Aerial robotics is a favorite. Yeah, Terra Expo. Yeah, those guys do really dope shit. They do really cool stuff. Can we apply multi-robot coordination to search and rescue? Yes, you can, right? The idea is you should just be able to keep track of where all the robots are, because the way multi-robots, if it's ask this question, I would assume you have some technical background. So let me explain it this way. The way multi-robots systems work is if you want it decentralized, it means one robot communicates either via LAN, Wi-Fi, or whatever to the next robot. It could also be Bluetooth, but that's bad. To the next robot, and then one robot, if it's 3-dimension, it's going to interact with roughly 6 robots in its environment. So it doesn't know the position of 2 robots apart, but it knows the immediate neighbor, right? So if you want to do something like search and rescue, you should also bear in mind that these robots will go extremely far apart. So a local area network might not be the best. you might be thinking of edge computing, where you have them all synchronized with cloud, and then you now have a control tower or a control station where you can see all of them, right? So that is multi, right? But now you are interfering, or you're interfacing with the robots, each of them, something like that. So it's doable and it can be applied to search and rescue. I'm not bashing humanoid robots, and then I go about to bash humanoid robots. No. I mean, I'm honest, because I've worked on them before, and I will still work on. Look, they pay very well, and you probably will still work on them if you have that applied to. How many robotic company are in Nigeria, and what is the job opportunities for us beginners? In as much as I really want to answer this question, somebody said Nigeria government know they support to. No, that's false. That's false. That's very, very false. It's not. It's wrong to say that. They might not have a big budget, such as Netherlands or Belgium or some other US budgets for robotics is insane. They might not have that big budgets, but they do. At least I know Unilag, the robotics community there. I'm very, very conversant with that one. And I don't want to go into details that I've earlier said, because on Friday we'll talk about that. On Tuesday, we'll also talk about how companies, which is tomorrow, we'll talk about how companies are actually sponsoring all these robotics things in Nigeria, like locally. So how many companies? There are quite a few, and the job opportunities, just stick around till Friday, and I would we also have a guest speaker that would run through all that. I've been in robotics since 2018. That's a long time. My final project was a drone built from scratch using 80 mega, chip and C++. That's a nice initiative. Since 2020, I graduated. No jobs. Material cost went high. I have apartment. I would address this on Friday, because there is something about understanding the terrain of where you're playing, right? You cannot be in Nigeria and you don't have the resources, and you want to go into hardware, or you want to go into the hardware side of robotics. It doesn't just really work out that way. But you see, this drone you built, you can also build it from scratch completely in software in form of simulations, and then it works pretty well. Simulations has gotten so real that even in research labs here in Europe, they don't work directly on the robots. If you want to try things out, you try it on simulation, and if it checks out before you switch to an actual robot. So you don't worry. One of the things that people did not believe is that you can do robotic simulation or robotic software simulation like very, very well and make something out of it. But this is actually changing, as our interns can see, and people who attended the last workshop too. So do I have another question here? Is the internship on site? No. It's completely remote. It's completely remote. The internship is completely remote. I've given the assignments, but I would also make an explanation later on. And will robotic software simulation be addressed in the workshop? That is the core of the workshop, right? That's one of the core of the workshop. And then at the end, we have actual robots that we can use to test them. We have a way to make all of those works. Don't worry about that. Okay, so now I can take Fortune, please. Your hands are up. What's the question?
All right. Good evening, everybody. Good evening, Mr. Bakel. Thank you for this opportunity. I really learned a lot. So my question is more like a clarity question, because I read in your slide that the curious mind should ask questions. So I wanted to type it, but I don't know the words to it. So I'm a recent graduate of prosthetics and orthopedic technology. For my final year project, we did a rehabilitative robotic arm. When I say robotic arm, something like that it was embedded and all those stuff, but it's a branch of my field of study. So as likened to what you said, that an option of your master's course was more like robotics. So that intrigued me to, explore more, because I noticed that my field here in Nigeria, they mostly do the traditional way of prosthetics. Those are artificial limbs and all. So those are like artificial limbs and all. But I really want to, evolve as my field of study is evolving, like gaining hands-on experience on the robotic aspects. That is rehabilitative medicine and all that. So I want to ask, because I want to know what is the link between this robotics and my field of study, because I also have a skill in AI and automation. I know you don't like AI, but I have a I have a skill in AI and automation. I actually build systems, workflows, and all that are currently in life now. So I want to know all this because my head is kind of in the clouds right now. So I want to ask, what advice you have for me? How do I move forward? Do you think robotics is a career path I should, go into and all that stuff? Thank you.
All right. So let's first start from your field, medicine and prosthetics, from what you said. I would give 3 different examples that different people on this call might relate to at different points in time. First of all, 2 weeks ago, I was speaking to I have in Aurora, we have a team that is focusing on medical robotics. Yes, we have a website, we have a community platform. Don't worry, we'll get all that on the group chat. So we have a medical robotics team, and we're speaking to them. We're trying to look at what research we want to go into. Okay, so we sort of were in on that, and then last night, because like when you're on Upwork, you get job offers and things like that. I saw a job offer for a contract that was on medical robotics, but what they wanted to do was surgery. So you have a robotic arm that would be used for surgery. Something like that, precision would be the key. Okay. So what does that tell you? That tells you there is actually a market for medical robotics. There is actually money going into medical robotics, because not only do I want to do something like that, but other companies are doing something like that. Now, let's leave that aside. There's a difference between there's a market for something, people want to do something, and if something has been done already, there's a video that I shared on our intern group. No, it was on the workshop group last year, where there was a man without an arm, and then they fixed his prosthetic arm for him, and the first thing he did was to smoke with it. But that video showed the illustration of how dexterous the arm is, right? So everybody, that video was cruise. It's like, see, person we God give second chance. That's what it's like, because they just fixed your arm and you're going to smoke. But to me, I actually know what it takes to have your palm or your fingers in the position to smoke for a robot. That's a lot of complex calculations, because yeah, that's on one side. So basically that's what they were showing in that video. That being said, some work has been done on prosthetics, which is that arm. So yes, the field exists. Now, if the field did not exist, then I don't think it's reasonable to pursue it. So we've established the first premise that the field exists. The next thing is, how do you now position yourself in that direction? First of all, you already do AI and automation, which is not holistically robotics, but then they share similar skill sets, right? At the same time, you have enough experience in the medical application So at this point, the only thing I see that is probably hindering you is the opportunity. That's the only thing I see, because since you already know the application of this side of robotics in medical field, and you already have some skill set, it's more like just brushing up a little things on robotics. Say, for example, for prosthetics, you need to be very, very solid with kinematics and inverse kinematics, because you are going to be moving things a lot. You are going to be solid with torque calculations. You don't want your motor to be too strong or too soft that it doesn't move the limb or move the person. You are going to be solid on tactical robotics or tactile robotics, which is the ability to give robotics feel and touch. So all these things are things that you are going to just learn here and there along the way. You must not know them. So yes, you can set yourself on that trajectory and start learning some of all these things. And then this is where the tricky part is. You now have to search for those opportunities. There are some, but very few opportunities, limited opportunities in Nigeria for robotics. Basically, the use of Da Vinci systems, things like that. You can actually take time and do research on that. Now, in the event that the sample size for companies that do medical robotics in Nigeria is too few or out of your reach, then I would advise that, okay, probably you should look for an international master's. Could be scholarship, you could fund yourself. But a lot of things changes the moment you leave the confines of Nigeria. You get more exposed to these opportunities. But for now, I am very sure that if we provide a roadmap for you, you are going to be able to understand clearer, and then you would progress in this direction. So overall, it's a very good direction to attempt. So there is a question which says, okay, it says, the CAD technician. I'm a CAD. Now, so funny enough, we took our time to do research on what you people might ask, what you people would want. On Thursday, there is a speaker that would come for just CAD and robotics, right? There's a speaker that will come for that. And the person would address CAD and its application in robotics. But from my own side, if I'm to simulate a robot, which is mostly what I do, like most of my work is software. And that's why I say people don't realize how much you can actually make or how much you can actually gain just doing robotic software, right? Because hardware is very expensive. Most companies do the software first before doing hardware, something like that. So from my own POV, we have a robotics mechanical engineer that does the modeling of these robots. I don't do the modeling. I rather not. So they bring the models ready for people that went through the workshop. We simulated this industrial process. The models are brought in form of either STL, OBJ, DAE, different technical terms, and we are the ones that sort of work with it using UDRF, Zacro, basically the whole ROS2 ecosystem. So there's a relationship, right? Before this robot was created, it was modeled, that kind of thing. But not everybody in robotics must be in every side of these things. Now, do we have a website? We have a website. Do we have a community platform? We have a community platform. I'm very sure the Y Robotics group is a subset of our community platform on WhatsApp. So don't worry, you are well covered if you're on the group. The link to the tags is not working. I'll put it up on the group. I'm pretty sure there's something somewhere. The link will be on the group chat here. Thank you very much for that, Abdullahi. Someone said I am a student of mechatronics and systems engineering at Bakel Bakel University, Bauchi. My goal and vision is to become a robotic special intelligence engineer. Yeah, I think I've been a bit too is specialized the word or is narrow the word? Because when you say something like robotics spatial engineer, what you're basically saying is you want to focus on spatial computing, like make the robots aware of three-dimensional world, but you're being extremely specific, right? Basically, this stuff is under perception, right? And perception contains a bit more things that will be helpful for you. But then the application that you are talking about is a robot that can spray, monitor and detect crops. That application is not, that's more like you want to do agricultural robotics than you want to do spatial intelligence. I usually tell people to be a bit more cautious about some because if you are strict on robotic spatial intelligence, then what you're going to be dealing with more often than not is the geometry of 3D spaces, reconstruction of 3D spaces, where you would have to take phototelemetry, and then you sort of reconstruct 3D spaces. That's what spatial intelligence actually is. You can apply it to agricultural robotics, but just applying does not make you a robotic spatial intelligence engineer, which by the way is a very long name. And again, I don't know if that is, I mean, I know what it means, but I don't know if that's like a job title. So I would say that you should, at the end of the day, you should probably align yourself with agricultural robotics, because that is not necessarily special intelligence. Because the guys that do special intelligence, they don't work with the plants per se. What they do is, what is that? We've heard of 3JS. That's the framework for, yes, 3JS is the framework for spatial stuff for JavaScript. We know of Open 3D, yeah, Open 3D, and some other things. That's what they really work with. Okay, so that's on that. Modeling, yes, but no, I don't. I rather not. What software do you specifically do? How does it differ from system engineering, embedded system? Yes. Now, what do I really do? I live in the terminal. That's what I do. I hate anything that takes me out of the terminal. I hate anything that takes me out of code and black and green. That's why I don't model. I can model and know how to use SolidWorks, but that should be the last thing. That's the last thing I'm going to do, and for a very high price. I rather recommend someone for it. Now, how is it different from embedded system? I want to show you something, but that depends on if your camera is clear enough to see it. Okay, good. So we look at a robot like this, and if you actually look at the back, you would notice there's like a board. This is like a USB, and there's actually a board inside here. There's a big board inside there, and that board is, this is the board that is inside there. This board. So if you actually look at it from the back, also, this is easier to access, but it's like a smaller version of the board. Okay, why am I showing you that? My job, or what I do, is to take this as it is, right? I would read the documentation for this. I would install the software I programmed to make this car move, and then I would put it inside this. That's my job as a software robotics engineer. And to do that, I use ROS2, I use RVs, I use Gazebo to confirm before I do it. I use a ton of other softwares, but in the terminal, VS Code, other, yeah, but basically nothing really. But now you see with this, you think of things like Rust tool chaining. You think of, first of all, let's break down what an embedded system will do with this. An embedded system engineer is the person that looked at this design of this board and said, this is where the vents or this fan motor should be. So he basically did a thermal assessment on the PCB design and was like, okay, let's put the vents here instead of up or instead of back or instead of where. So that's what embedded system actually, they take this whole thing, this is what they work on. And I kid you not, it's very different. I know people like me now, I use Arduino, I use the Arduino IDE, I use ESP. That's when I want to code on the embedded system, right? I'm not actually, so for people that know how to write Arduino, and I'm very sorry, that's not really embedded system. I mean, it's an application of embedded system, but it's not all that it is, right? So this, I hope I'm able to get some, it's not Arduino in the mode. I mean, Qualcomm acquired them and then they have a SBC now, so it's pretty up good, right? But I'm saying you can't do only Arduino and say you're an embedded system. Come on, even I do more than Arduino and I'm not an embedded system engineer. Also, will a highly competent embedded system engineer excel at robotics? Yes, but it's a matter of interest, right? I have a friend that he hates coding, right? He hates anything. He prefers working with oscilloscopes. He prefers working with soldering irons. He prefers working with things he can actually touch. And if it goes wrong, he knows that, okay, probably I didn't solder this line correctly. I'll clean this. He prefers things that he can actually see. And whereas some of us, what do? We prefer mental constructs, right? We prefer the philosophy of computer programming languages. We prefer the software. We prefer doing. It's a matter of preference. Okay. I'm also going to succeed as an embedded system engineer, but I rather not. Yeah. I'm not going to go into embedded system. Okay. Circling back. Okay, so you spoke about an opportunity that came up on prosthetic. Can you do a walkthrough on how you can actually get opportunities in this field? I can, and it's something I usually do. It's just something I did not. I mean, it's a very detailed topic, and we will talk about it on Friday in details. I can even explain how I got into the field, but just know that the opportunities are like flying all around. The easiest thing to do is for you to position yourself that the opportunity sees you rather than applying, because there's difference between you applying to many companies and companies writing to you. But before companies can write to you, you should put yourself out there. You should be visible. As you can see, one of the definitions is, oh, this guy is social presence. I build social presence, so it's easier for me. Now, if you don't want to build social presence, what you should do is your GitHub repo should not be dry. I can someone is applying for a job about software, and then I open your GitHub repository or your GitLab, and then I can't see anything. So which evidence do you want to show me? Anybody can put anything on a CV, I swear to God. Anybody can write the perfect cover letter with ChatGPT, but evidence, see, tangible evidence, that's the idea. So I'm heavy on documentation. I'm heavy on documenting your work. So like it's a thing of joy when somebody messages you and say, hey, we came across your profile, or we came across your GitHub, or we came across this, and we see that you do this. And then another person is carrying his CV up and down without any form of evidence. I don't really understand how does that work. So that's something that can also guide you. Now, how does 3D web development play a role in robotics? So there are some ambitious people who decided that, you know what, let's not control the robots with our laptops or with our controllers. Let's control it over the internet. Okay. And I worked on something like that where we used a website to control the robots. Okay. But that's one thing about robotics. With the opening of one problem comes another problem. And then somebody says, okay, let's stay from another country and control the robots in another country. Case study of a Kuwait company in February 2024, where I stayed in Spain and I was busy controlling the robot in Kuwait because it's connected over the internet and we're using a website to do it. Splendid. But then another problem comes. You are in Spain, you cannot see the surrounding of the robot. So what do? You decide to create a 3D model of the room so that I can see the surrounding. And what you now do is you have a LiDAR, you have a camera, and you sort of sensor fusion, you fuse it all together. But now you have to show that 3D model you've created on the website. And that is where 3D web development comes in. So now, at times in robotics, I find myself studying things that I have never, like, I can just see the tax for the day and I'll be like, oh my God, do I tell them this is not my skill set or should I just go and learn it? And I just end up learning it because the assumption is, oh, this guy is doing robotics, he can do it, right? So that's how you end up learning 3D web development for robotics, and that's how it plays the role. You don't really need it, but it's because the criteria of the robot keeps on adding and always building something, and you somehow need to go and get that from there. So one thing that needs to be cleared is that there are a lot of similar concepts in robotics that don't mean the same thing. Yes, there are a lot of very similar concepts in robotics that doesn't mean the same thing. Someone said terminal, using computers as God intended. You just need to attend the workshop and see the premium cruise you catch with terminal. Because like for the people that attended that workshop, like the poetry at the terminal, like you actually feel like a god when you do things from the terminal. Like there is this ego and like, God, I can root and unroot things. So yeah, we live in the terminal. So yeah, terminal usage is actually termed CLI, command line interface. True, you can also have that there. When you're working on Azure and they're like, oh, Azure CLI, that's what it works. That's what it's Arduino in the mode. Arduino will forever be in the mode. No, I'm just joking. But the people that feel they've achieved with just Arduino, it's not really ideal. Yeah. Princess said, "Bam, hardware enthusiast." Okay, what else? You mentioned Rust. I assume that's the language you use. What about frameworks? No, I don't use Rust. I've only used Rust once, and that was when I needed to write embedded. I needed to program a fitness watch, and that's when I used Rust and Rust toolchains. But I said Rust. Rust is different. Rust 2, Rust 2. Rust 2 is the framework itself, but the languages we use is C++ and Python. You can also use JavaScript, but plus or minus, there are different things there. But C++, yes, we love C++. We also love Python, but with side eyes. I'm glad the class is recorded. I mean, we all are. I'm only familiar with Arduino, ESP, and then STM, and some other microcontrollers. I studied human anatomy, and I'm transitioning into tech with a focus on software engineering. I also did a PhD in IT and have begun learning independently. With this background, will it be advisable for me to participate in the internship program? Yes. Now, why? There's a problem we always come into. Robotics is a mix of different fields, right? There was a shock I had. Somebody participated in the workshop, won an award, was offered an internship, accepted the internship, and then I randomly saw on his status I was going for a accounting competition and a business competition. And then I was like, what do you even study exactly? But then I also remembered myself that I'm not even robotics per se. I just happen to be good at it. What am I trying to say? The way the internship is structured, for those that participated, we try to carry everybody along. Now, what I mean is, if you do not know, so there's usually a form that comes out every year where you tick your skill sets. So there's a list of like 12 different skill sets. from if you are very good at it to if you are not good at it, and then you tick. Now we use that skill set to design the schedule or the timetable. So there were people that a lot of people last time that didn't know anything about programming. So we had to create weekly classes, like weekend classes for programming, without affecting the main robotic stuff, so people can keep up. And then in contrast to the last time, now we have a lot more mentors that would be able to handle people's personal questions. So you pretty much I would love to attend that. Oh, Rust too. Okay, JavaScript. Why is it everywhere? Why is JavaScript everywhere? I don't know. I don't know actually. But it's very efficient, and then they build other languages on JavaScript. But JavaScript is not what we use. It's uncommon to see JavaScript, but considering my own point of view, I've used JavaScript a lot. C++ all the way, exactly. Like nothing is replacing C++. An aspiring mechatronics student. If I'm passionate about mechatronics in general, fascinated by robotics, I'm always eager to asking. I want to go into the workshop so bad. Of course, it's open to everybody. How do you get the learning resources you use when you come across a problem? You don't have any. I don't have any idea. Okay, so this is classic me, right? More often than not, I don't have any idea about the problems. Like the problem comes and say, for example, let me use an example that I've talked about. I talked about the whole we want to be able to control our robots over the internet from a very far distance. So something like that. I didn't have any idea of what to do about it, but I started breaking it down. First of all, if I can send from my PC to the robots, if I can send like a command over the internet, right? So then you Google how to do that, or you tell ChatGPT and ask it how to do that, and then you suddenly find out that, oh, you probably need to use APIs, the common get post, all of that, and then you can send commands. What you just need to do is, if you are sending a JSON with move and maybe 10 meters, on the other side, yes, you can do it over HTTPS, you can do it over MQTT, you can do it over HTTP, not HTTP or HTTPS. Yes, you can do it. You can share MQTT too. So all you need to do is you now install on the, and then your robot can act as a client. So then you install on its own side, so that if it receives your move 10 meters, you now translate it on the robotic software. So it's a whole pipeline, but if you break it down, it's something that you do. More often than not, you get confused. But there's something I like doing. So when I give a task to the interns, I would give you like 5 days to go and figure it out by yourself. You take some time to actually think, right? So after 5 days, if you can't get it done, then we'll get it done together. Well, sometimes in those 5 days, you find out that we are actually capable of thinking of these things ourselves and actually learning them ourselves. So yeah, that's the whole idea. All right, so is there any more questions? If mechatronics is the parent field and areas like embedded and is the follow side, can I focus on building robots while staying in mechatronics, or would I mean, what do you mean by switch? Do you mean by staying mechatronics, by studying mechatronics? You can still do you can still do your PhD or master's in mechatronics. Again, let me re-emphasize, let me restate this. I am still in naval architecture. I'm still a naval architect. Doing robotics doesn't change the fact that I studied as a naval architect, right? The same way all you need to just learn the extra skills, and on your CV, a BSc in mechatronics is nice for robotics. right? A BSc of naval architecture, on the other hand, is not so good on my CV, so I don't really include it, right? The only thing I just include is my work experience, and it gets things done for me. Robotics is a very practical field than a theoretical one. So I've always loved building things, from self-driving cars with Arduino. I doubt that car is self-driving on Arduino, to automatic trash can. Okay, fair. And I want to keep pursuing that. Yes, keep pursuing that. The reason why I said you cannot build a self-driving car on Arduino is because you cannot connect those type of sensors that make it self-driving to Arduino. So it's just counterintuitive. But I appreciate your project so far. Very nice one. All right. So I'm going to yes, use an ultrasonic sensor. I'm aware that's what you're going to use, but then the ultrasonic sensor is only about 10 meters, 10 meters of range, and then the best you can do is to put it on a motor that rotates, but then you are limited by the speed of that motor, meaning there's going to be a lot of blind spots and it's not completely self-driving. I've thought of all those possibilities. I know what you're saying. Right, and it's a hobby, so it's great. It's excellent. It's excellent. I'm just being keen on the terms, right? That's what I'm being keen on, the terms. So I'm also studying computer engineering. We focus on this. I've been practicing with. What do you advise to give me? Keep on practicing with what you have. You can also get into the workshop to probably get a clearer view of how things are. So yeah, basically. All right. So, any more questions? We are going to, because we're already over the duration of the call by an hour. So, any other questions, we would have them on the group chat. Then we're also going to do a bit of a recap when we figure out the whole issue with joining. So we'll do a bit of a recap. All right. So thank you very much for joining. I still remain Bakel, and we'll talk more in the group chats.